Ever wondered how an electric car can slow down and recharge its battery at the same time? It sounds almost like magic, right? But it's not. It's pure physics and brilliant engineering, a system called regenerative braking. This technology is one of the key reasons why electric vehicles are so efficient. Instead of wasting energy every time you hit the brakes, regenerative braking captures that energy and gives it a second life. In this video, we're going to break down exactly how it works from the science of motion to the electronics inside the motor, and we'll look at why it's such a game changer for the future of transportation. Let's start with something simple. Every moving object has kinetic energy, the energy of motion. The faster you go and the heavier you are, the more kinetic energy you have. When you're driving a car at, say, 60 miles per hour, that car's kinetic energy is enormous. In a gasoline car, when you press the brake pedal, all that energy has to go somewhere, and in traditional braking systems, it just turns into heat. The brake pads press against metal discs. The friction slows the car down, and that motion energy becomes thermal energy that's lost into the air. It's basically wasted energy. Electric cars, however, think differently. Instead of wasting that motion, they use it. The same motor that pushes the car forward can also work backward. That's the foundation of regenerative braking. When you slow down, the motor switches from being a consumer of power to a generator of power. It takes the kinetic energy from your car's movement and converts it into electrical energy, sending that electricity right back into the battery. It's like turning your car into a mini power plant every time you slow down. Now, let's dig a little deeper into how that is even possible. In any electric car, the main drive unit is an electric motor connected to the wheels. When you press the accelerator, the battery sends current to the motor, creating a magnetic field that spins the rotor and drives the wheels. When you lift your foot off the accelerator, though, the car's computer can instantly reverse the current flow. The magnetic field inside the motor starts resisting the wheel's motion, and that resistance slows the car down. But here's the genius part, that mechanical resistance produces electricity. The motor is now acting like a generator, feeding current back into the battery pack. This process is governed by one of the most fundamental principles in physics, Faraday's law of electromagnetic induction. It says that when a magnetic field moves relative to a conductor, it induces an electric current. In simpler words, if you spin a magnet near a coil of wire, you'll generate electricity. That's exactly what happens inside an EV motor during regenerative braking. The spinning wheels turn the motor's rotor, which induces current in the stator windings, and that current flows back to charge the battery. But regenerative braking doesn't just happen on its own. It's carefully managed by a system of sensors and control electronics. Modern EVs use sophisticated software to determine exactly how much regenerative braking to apply. If you're coasting gently, the car might use mild regen, slowing down smoothly and topping up the battery a little. If you're coming to a stop quickly, the system increases the regenerative braking force. However, it never applies more than the tires can handle otherwise. You could lose traction. That's why EVs rely on brake-by-wire systems, which blend regenerative braking with traditional friction brakes seamlessly. Then, let's imagine this in real driving terms. You're approaching a red light in a Tesla. You lift your foot off the accelerator. Instantly, the car's inverter changes how current flows through the motor. You feel the car begin to slow. That's regenerative braking at work. The dashboard even shows energy flowing back into the battery. If you continue to slow down gently, you might come to a complete stop without ever touching the brake pedal. But if you need to stop faster, the system automatically adds the mechanical brakes. To you, the driver, it feels natural and smooth, but behind the scenes, a lot of smart engineering is happening every millisecond. One of the best things about regenerative braking is energy recovery efficiency. Depending on the vehicle and driving conditions, it can recapture anywhere from 50 to 70% of the energy that would otherwise be lost. That's huge. Imagine driving through city traffic stoplights, slowdowns, and constant braking. In a gasoline car, all that energy is wasted as heat. In an electric car, each slowdown sends energy pulses back into the battery. Over time, that adds up. It's one of the main reasons EVs perform so well in city driving compared to highway driving, because there are more opportunities.
Extra air. More air means more fuel can burn. Extra air. More air means more fuel can burn, which gives you...
Now you might be wondering, how does this affect the feel of driving? That's a great question. In some EVs, regenerative braking is very noticeable. As soon as you lift your foot off the pedal, you feel strong deceleration. The car slows down aggressively. That's sometimes called one-pedal driving, because you can control both acceleration and deceleration using just the accelerator pedal. Tesla, Nissan, and Rivian have all refined this feature so you can practically drive around town without touching the brake pedal. Other manufacturers like BMW or Hyundai allow you to adjust the regen level from light coasting to strong braking, depending on what feels best to you. But regenerative braking isn't only for fully electric vehicles. Hybrid cars like the Toyota Prius have been using versions of this technology for decades. In a hybrid, the regenerative system works together with a small gasoline engine. When you brake, the electric motor generates power and stores it in a smaller battery, which is later used to help the engine accelerate more efficiently. Even plug-in hybrids and mild hybrids now use regenerative systems to improve mileage and reduce emissions. So while EVs have made it famous, regenerative braking is actually a key part of modern automotive engineering across the board. Let's look at what's happening technically during regenerative braking. When you're accelerating, current flows from the battery to the motor. The inverter controls the current by adjusting its frequency and voltage, creating a rotating magnetic field that keeps the motor spinning. When you lift off, the inverter changes its role. It becomes a rectifier. Instead of sending AC power to the motor, it takes the AC power generated by the motor and converts it back to DC power for the battery. The control system monitors voltage, current, and temperature to make sure the battery isn't overloaded during this process. It's a delicate balance between recovering as much energy as possible and keeping everything within safe operating limits. Now let's talk about the limitations. Regenerative braking isn't perfect. It depends on a few conditions. First, if your battery is already fully charged, there's nowhere for the recovered energy to go. In that case, the system reduces or disables regen to protect the battery. Second, temperature matters. In cold weather, battery chemistry becomes sluggish, and it can't accept charges quickly, so regenerative braking power is reduced. That's why some EVs show a regen-limited warning on cold mornings until the battery warms up. Third, at very low speeds below a few miles per hour, regenerative braking loses effectiveness because there's not enough rotational energy to convert. That's when traditional brakes take over completely. Another challenge is driver comfort. Engineers spend a lot of time tuning the feel of regenerative braking to make it natural. Too aggressive, and it can feel jerky. Too soft, and it feels unresponsive. The blending between regen and friction braking has to be seamless, so drivers never notice the transition. Modern systems like those in the Porsche Taycan or Hyundai i95 use advanced algorithms to calculate brake torque hundreds of times per second, ensuring smooth deceleration under all conditions. The impact of regenerative braking goes beyond just efficiency. It also reduces wear and tear on the physical brake components. In traditional cars, brake pads and rotors need replacement every 30,000 to 50,000 miles. In many EVs, they can last well over 100,000 miles because they're used far less often. That means lower maintenance costs and fewer replacement parts, which also reduces environmental waste. So, regen braking doesn't just save energy, it saves money and materials too. Let's put some numbers to all this. Suppose you're driving a 4,000-pound car at 60 miles per hour. The kinetic energy at that speed is about 490 kilojoules. That's roughly the amount of energy a 100-watt light bulb uses in 80 minutes. In a conventional car, almost all of that is lost as heat. But if your EV can recover even 60%, that's almost 300 kilojoules of energy returned to the battery in just one braking event. Multiply that by hundreds of stops over a week, and you're talking about real, measurable range gain. Now, not all regenerative systems are created equal. There are two main types: mechanical electrical systems, like those in most EVs, and electro-hydraulic systems, used in some hybrids and performance cars. In the first type, the electric motor handles most of the braking through magnetic resistance. In the second, a hydraulic braking system is electronically controlled to maximize energy recovery while maintaining pedal feel. Some performance EVs even use dual motor setups, front and rear, allowing the system to distribute regenerative braking across all wheels for better balance and stability. Future technologies are pushing this even further. Next-generation EVs are experimenting with ultra-capacitors that can absorb and release energy much faster than batteries. These could capture more braking energy in short bursts, especially during aggressive driving. There's also research into smart brake-by-wire systems that use AI to predict how much braking force will be needed ahead of time, optimizing regen for each situation. Even Formula E, the electric racing series, uses regenerative braking strategically. Drivers actually adjust the regen strength mid-race to manage battery temperature and energy reserves, just like fuel strategy in Formula One. One interesting innovation is blended regenerative braking integrated with autonomous driving systems. Self-driving EVs use sensors and predictive algorithms to anticipate when braking will be required. That allows them to start regeneration earlier and more smoothly than a human driver could, maximizing energy recovery while keeping passengers comfortable. As cars become more intelligent, regenerative braking will become even more efficient. So what does all this mean for you as a driver? It means your EV isn't just efficient because it runs on electricity. It's efficient because it's constantly recycling energy. Every time you coast downhill, every time you slow for traffic, every red light, your car is quietly capturing and reusing power that would otherwise be lost forever. That's a level of energy management no gasoline engine can match. And beyond the individual benefits, regenerative braking is part of a bigger shift in how we think about energy. It's a small but powerful example of circular energy flow, taking waste and turning it back into usefulness. It's the same philosophy behind renewable energy systems like solar panels and wind turbines. Instead of burning resources once and losing their potential, we loop the energy back into the system again and again. That's how we move toward a truly sustainable future. Still, there's room for improvement. Engineers are working on ways to make regenerative braking even more effective. For instance, pairing it with active suspension systems that can harvest energy from bumps in the road, or integrating it with thermal management systems that reuse the heat from braking to warm the cabin or battery. The future EV might not waste a single joule of energy. In the end, regenerative braking is one of those elegant ideas that just makes sense simple in theory, complex in execution, and brilliant in results. It turns every slowdown into progress, every stop into potential, and every journey into a lesson in efficiency. So next time you're behind the wheel of an electric car and you lift your foot off the pedal, take a moment to appreciate what's happening. Invisible forces of magnetism, motion, and electricity are working together in perfect harmony, turning energy that would be lost into energy you can use again. That's regenerative braking, one of the smartest, most efficient, and most fascinating technologies driving the future of transportation.